Okay, good day everyone. So we will continue the topic of arithmetic logic instruction and programs. I believe that we have stopped our lecture with regards to the division of the unsigned numbers. And we shall continue by illustrating another example by a division by application. And we have this example: a sensor connected to an ADC, and the ADC represents some quantity such as temperature or pressure. The 8-bit ADC provides the data in hexadecimal in the range of 00 up to FF hexadecimal. This hexadecimal data must be converted to decimal. How should we do that? So to do that, we can divide it by 10, the hexadecimal, repeatedly, and saving the remainder. So by dividing, actually it's not dividing, by subtracting it by 10, subtracting. So illustrating it, we have here an example. Assume that we have the data memory location 0x315 and has a value of FD hexadecimal. The instruction is to write a program to convert it to decimal and save the digits into the location 0x322, 0x323, and 0x324, where the least significant digit is in location 0x322. So the least significant digit is 0x322, the middle is 0x323, and the most significant or the highest significant bit is 0x324. So first, we have to declare the location 0x315 in hex num, and the least significant bit, the ramp and L, is 0x322. The middle part is 0x323 in location, and the highest significant bit is 0x324. And we will be defining the numerator is equal to R20 and the denominator is R21. And the quotient will be defined by register 22. And then we load the value of 0xFD in register 16 and store the register 16 in hex num or in the location 0x315. So now we have hex num loaded to the num or the numerator, and we have LDI immediate, the denominator having a value of 10. So by our goal is to divide it by 10, right? And so we'll have, first is we have a loop, then increment it by a quotient, increment it by 1, the quotient. So first is first nato na loop is na siya 1 nga quotient. Quotient is equal to 1. So next instruction is subtract the numerator to the denominator. The numerator here, katong sa num here, ang atong value sa R16 is 0xFD or 253 in decimal. So 253 minus denominator. So 253 first is 253 minus 10 is 243, and so on. 243 minus 10. Repeated na siya. Branch if carry is equal to 0. Kung ang carry is equal to 0, mag-branch siya. Pero kung dili, mo proceed na siya sa next instruction. So 243 minus 10 is 233. Carry is equal to 0. Until mahimo na lang 3 minus 10. And so on naman eh. 3 minus 10 is equal to negative 7. In this case, our carry now is equal to 1. So, pero ang quotient nato, maabot na nag 26 ka balikan. So, 26 na ng quotient nato dira. So, after that, this 26 will be decremented by 1. So, 26 minus 1, our new quotient is equal to 25. And then, the latest norm na value nato is, pila man ang atong latest na norm. So, 3 minus 10, negative 7. Mao na atong norm is equal to negative 7 na. Negative 7 na ni ang norm, pinaka latest. So, negative 7 plus 10, pila man, is equal to 3. And then, this 3 will be stored again sa norm. And this will be our new norm, 3. So, this 3 here will be stored sa RAM and L. So, our RAM and L is equal to 3. Now, our norm is equal to 3, right? So, ganina. But, here, ingon siya, ang value daw sa atong quotient, i-move nato sa norm. Our quotient is equal to 25. So, our new norm here in this line is equal to 25. And then, load the 0 value into the quotient. For in this case, our new quotient value is equal to 0. And here, sa loop 2, increment daw nato ang quotient. Quotient is equal to 0 here. Increment it by 1, so we have 1. Then, sub norm denominator. Our new norm is 25, right? Minus 10. Then, carry is equal to 0. And then, branch BRCC loop 2. Balik siya sa loop 2 kung carry nato is equal to 0. So, balik siya dire, mo increase na pod ang atong quotient. So, mahimo na ng 1 plus 1 is equal to 2. And then, sub norm. Norm na pod is, ang atong bagong norm is 15 minus 10. Carry is equal to 0. Branch na pod siya kung C is equal to 0. So, plus 1 na pod kadira. And then, 5 man atong bagong norm, 5 minus 10. Atong carry is equal to 1, kaya negative 10 naman. So, i-break nato ang pag-loop niya kung carry is equal to 1. So, dire na siya. So, our quotient now here is equal to 3. Mo na pinakalas. So, decrement it by 1. So, 3 minus 1 is equal to 2 na atong quotient. Then, our norm here, ang pinakalas nga norm is equal to negative 5. So, negative 5 plus 10 is equal to 5. So, our norm new here is 5. Norm is equal to 5. So, 5 here will be stored sa RAM and M. So, our RAM and RM and D underscore M is equal to 5. And then, next instruction is store the quotient in RAM and H. RAM and H is equal to the quotient. Our quotient is equal to 2. So, our RAM and L is 3. Our RAM and M is 5. And RAM and H is 2. Or 2, 5, 3. So, this would be the value of the decimal of the hex na FD. So, it would be stored respectively here. So, 0324 is 2, 0323 is 5, 022 is L. Okay?